Okay, so like I said before, the beginning of 6.6, we just went through kind of different types of problems of reviewing what the properties are of any quadrilateral, right? Today what we're looking at is if I give you 4 coordinate points, can you tell me from the very start, go through all the work to show me what type of a parallelogram, or not parallelogram necessarily, but what type of a quadrilateral it is, if it's anything special. This right here, so I want you guys to listen to what I say. This is a suggested method to finding it. It is not necessarily the shortest way to do it, though. This is just to help people who really don't know where to start. It kind of gives you like, okay, here's what you could do next. Now, keep in mind that there's a few different ways that you could check for a parallelogram, right? Like a parallelogram, you could check that all the slopes are the same, and that's what I'm suggesting that you do. But you could also check to see if if the distances of opposite pairs of sides are the same, right? Or you could just check one pair of opposite sides for same slope and same distance. So there's multiple ways to do this stuff. This is just something to help you if you are just so lost that you just don't even know where to start. It's just to kind of give you a nudge, all right? Don't get hung up on this. A lot of times when you're working through a problem, there's going to be a way to do it with less work than what this will recommend doing. Does that make sense? If you're watching out for some key things. Let's just go through this. What you can always follow this for is to follow like which categories you're in. This stuff right here on the arrows is just a suggested thing to check for. But no matter what, your first step is always going to be to figure out if you're in the parallelogram category or if you're going to be in the non-parallelogram category. That has to happen first no matter what. I suggest to you guys to find all 4 slopes of the sides because it will tell you if it's a parallelogram, if you have both pairs of opposite sides are parallel, right? And if it's not, it'll also dump you into this category if it's not. Because since you've checked the slopes, should you know at this step whether it's a trapezoid or not? Do you see what I'm saying? If you've checked all the slopes and you don't have 2 pairs of congruent sides, do you at least know if you have 1 or none? So that will automatically funnel you into this path or this path over here. That's why I'm saying that would be the most efficient first step, is just to check all the slopes. The slope formula is also easier than the distance formula, right? So that's also something to keep in mind. Once you're in these categories, I've given you suggestions of how you can check to see, like, if you're in a parallelogram, I think it's easiest just to look at your diagonals, because then you only have to do 2 computations rather than checking all 4 sides, right? But sometimes if you guys are keeping in mind all the properties that are true about a certain figure, there are things that you can do that might seem easier. I'm going to do some of that in the examples. So one way you could do this, to see if it's a rhombus, you could check to see if you have perpendicular diagonals. What's another way you could check to see if something's a rhombus? You know it's a parallelogram, right? So what's another way that you could see if something's a rhombus? And to see if it has all equal sides, do you really have to check all 4? You already know, if it's a parallelogram, don't you already know that the opposite sides have to be equal? So don't you really only have to check to see if 2 consecutive sides are the same? If it's a parallelogram and consecutive sides are equal, everything has to be equal, right? When you're looking at a rectangle, I've suggested that you can look at the distance formula of diagonals. There's actually an easier way to do this if you're keeping an eye out for it. How do you describe this angle right here? What? 90 degrees, which 90 degrees is the same thing as saying that 2 lines are not consecutive necessarily. 2 lines can be consecutive and not form perpendicular lines, right? How do you know if 2 lines are perpendicular? Yes, if the angle adds up to 90. But in a coordinate plane, how are you going to check to see if 2 things are perpendicular? Opposite reciprocal slopes, right? Haven't you guys already checked all the slopes up here? So shouldn't you be able to look at consecutive slopes and see if they're opposite reciprocals at this point? Right? And then you don't even have to do any extra work. So that's something to watch out for, is that you can avoid having to even do this work if you're watching things up here. Again, this is just something you can follow if you really aren't catching all the little details as you go. So we've talked through how you could see if something's a rhombus. How can you see if something's a rectangle? From here, if they're both rhombus and rectangle, it's a square, right? Or it could be one or the other. Or it could just be a regular old parallelogram that's not a special one. That's also an option. It does not have to be one of these three things if it's a parallelogram. It could just be a plain old parallelogram. If you find yourself in the non-parallelogram category, let's say that you saw that, I had up here in this step, you saw that you had one pair of opposite sides. How are you going to check to see if something's an isosceles trapezoid instead of just a trapezoid? My suggestion was to check to see if you have congruent diagonals. What's another way that you could check to see if something is a isosceles trapezoid? What else is congruent down here? The bases? No, that base is not congruent to that base. The legs, which are your non-parallel sides, right? So you could also, instead of checking to see if the diagonals are congruent, you could check that pair of non-parallel sides to see if they're congruent. So that's easy enough. If you had 0 pairs of opposite parallel sides, it might be a kite, or it could just be a regular old non-parallelogram, which is just a regular old quadrilateral. That's an option too. It does not have to be a kite. How do you check to see if something's a kite? What's the easiest thing you can do? What do you know about the sides? Two pairs of consecutive sides. That's the easiest thing. I will caution you guys that a kite has perpendicular diagonals. That's true. But you can have a quadrilateral that has perpendicular diagonals that's not a kite. So that's not a good enough check. That's why I didn't put that here. It seems like that would be more efficient, but I could draw you a quadrilateral that's not a kite or a rhombus that has perpendicular diagonals. Okay, so don't get caught up there. For the kite, you always want to be checking the distances of the sides to see if you have 2 pairs of consecutive congruent sides. We ready to try an example? Again, this is just if you need a little nudge in the right direction. Try and do it without having to look at this. Just use what you know about a figure and ask yourself, okay, what would I need to show in order to prove this thing? Okay? All right, so I want to know what kind of a quadrilateral is ABCD. Make sure that you are showing me all of your work like we've always done with a label of what you're trying to find, the formula setup, any work that you need to show, and an answer. It should be in a neat, clear, easy-to-read line for me. Once you've done your work, tell me what each piece of work tells you about the sides or the diagonals. In other words, tell me whether this means parallel, perpendicular, or congruent. That's what I'm looking for there. Once you've told me what it means about those diagonals or the sides, then you can tell me you can conclude what you know about that thing then. Like what kind of a figure could it possibly be, or if you can eliminate a certain type of figure, what could you eliminate? Okay? So you'll see how this is all going to go. All right, so what do we have to check for first no matter what? We have to see if it is a parallelogram or a non-parallelogram first. What did I say is the most efficient way to start this then? Find the slopes of all of the sides, right? To see if you have 0 pairs of parallel sides, 1 pair, or 2. That will tell you whether you're checking to see if you're a kite, checking to see whether you're a trapezoid, or checking to see whether it's a rectangle, square, rhombus thing, okay? So start your work with your label. So if I'm finding the slope, how do I start my label? M, very good. So I'm finding M of, and what should I also be doing right now before I start? I should draw a little sketch so I can see where which sides are opposite to each other, where are my diagonals, things like that. Because you can really mess that up if you accidentally start just picking random letters. You might not get opposite sides, and then you're drawing relationships that don't mean anything whatsoever. So I'm just going to draw a quadrilateral. I'm not going to make it look like anything special per se, because I don't want to get hung up on my picture. Okay, and then I'm just going to go around in order A, B, C, D. So now I can see where my opposite sides are. Which slope do you get? We're going to have to find the slope of all 4 of these things, but which slope do you want to find first? A, B. Easiest to start, right? Okay, so the slope of, and then I'm going to give it that label, AB equals, show me your setup at least. So for AB, your slope setup should be 8 minus 5 over 1 minus a negative, but minus a negative is plus 2. So I'm going to have 8 minus 5 all over 1 plus 2. I'm going to do this simplification in my head. So 8 minus 5 is what? 3 over 1 plus 2? 3 over 3 is 1. Okay? Which slope do I want to compare AB with? So if you're looking at this figure, I need to compare the slope of AB with its opposite side, which is going to be CD. Okay? So I'll compare that with the slope of CD equals yep, 2 minus 5 over 1 minus 4. Very good. Okay? Do the algebra or the arithmetic. You've got 2 minus 5 is, and 1 minus 4 is. So negative 3 over negative 3 is 1. So what do you know right now?
At least there's one pair of opposite sides.
I at least have one pair of parallel sides. I'm going to wait to write my conclusion until I have all of my slopes. And at the end, I'm going to say, like, either I have 2 pairs of opposite sides that are parallel or 1 pair. I'm going to write my conclusion once I know it all, right? So which slope do I want to find next? What? BC. Yep, we now have to start checking this opposite side with this opposite side. So the slope of BC equals, and if you look, you've got 5 minus 8 over 4 minus 1. Okay, so 5 minus 8 is negative 3. 4 minus 1, positive 3. So what's negative 3 over positive 3 simplified to? Negative 1. Now remember, I told you that you also kind of want to be watching out for the relationship between the consecutive side slopes. Remember, consecutive sides might be right angles. Are these opposite reciprocal slopes? Yes, right? 1 is a reciprocal of itself. If you wrote 1 as a fraction, it would be 1 over 1. Reciprocate it, it's going to be 1 over 1, right? And it's an opposite value of it. So I know at least one of my sides is perpendicular. If I get another side with that same slope, what kind of a figure do you know this is going to be? Parallelogram, and specifically with perpendicular lines, a rectangle, right? If it's a parallelogram, it could be just that regular parallelogram. It could be a rectangle, a rhombus, or a square. If it has perpendicular sides that are consecutive, it has to be a rectangle at least, right? But we need to know if that last slope matches. So what is our last slope that we have to look at? AD. Okay, so AD slope is going to be 2 minus 5 over 1 minus a negative will be plus 2. So 2 minus 5 over 1 plus 2. All right, so 2 minus 5 is over 1 plus 2. So this slope simplifies to be negative 3 over 3 is a negative 1. All right, now I have all of my slopes, so I want to draw my conclusion and say what is the most I know right now, right? So here's where you draw your little bracket business. Okay, so first of all, how many pairs of opposite sides do I have that are parallel? So I would say 2 pairs of opposite sides are parallel. Which means what? That tells us it's a parallelogram, right? And I kind of talked you through watching out for, you can at this stage always tell me if it's a rectangle. It will be a rectangle if it's a parallelogram and you have opposite reciprocal slopes between your consecutive sides. What if those weren't opposite reciprocal slopes? Could you say for sure that it's not a rectangle then? Yeah, if you don't have opposite reciprocal slopes, is it possible to have a right angle there? Not without opposite reciprocal slopes, right? So at this stage in the game, you really should be able to look at this relationship and tell me if it's a rectangle or not a rectangle, right? If you're watching out for that. If you're not watching out for that, you can follow the chart and do a little bit of extra work to really convince yourself. But if you stop here and take a look at this relationship as well, that will tell you enough about a rectangle or not a rectangle. In our case, we're going to say that consecutive sides are, what's the word I'm going to use, or the symbol? Perpendicular, right. So I'm looking at my consecutive slopes, and I'm saying my consecutive sides are perpendicular, which tells me that this is a rectangle. Now, do I get to just stop and be like, yay, it's a rectangle?
No, because it could be square.
It could be a square, and I need to see that work. If you guys just stop and it's a rectangle, and it actually is a rectangle, I'm going to say, that's great, that's the right answer, but you haven't shown me any work to convince me it's not also a square, right? So you need to now show me that it's a square or not a square. So what do you know about a square? Perpendicular diagonals, or what else could you check? Congruent diagonals are in a rectangle, which we already know. But what is congruent in a square? Sides. And remember, you don't have to check all four sides. Since it's a parallelogram, you already know those opposite sides should be congruent, so you would really only need to check to see if one pair of consecutive sides is congruent. Either way will work. So you can either do perpendicular diagonals or one pair of consecutive sides for distance. What do you guys want to do? So you want to look at congruent sides? Yeah? Okay, that's probably what will make the most sense to you guys. A lot of you guys will probably have a harder time with the diagonal. So if you're confident with the diagonal property, that's actually an easier computation because it's slope, right? However, it probably makes more sense to you guys to think about, well, a square has to have all equal sides, so if I just check the distances, that's enough, right? So let's do that. We'll check the distances of the sides. So you said you wanted to find AB. All right. So what is the distance of AB? Got that?
In parentheses.
What number?
-2.
Okay.
-1.
There you go. Difference in the x value, so -2 minus 1.
Squared.
Square it.
Plus.
Plus.
In parentheses. 5 minus 8 squared.
Very good. 5 minus 8 squared. Okay. We can probably go through and do this work in our head at this point. So I remember I don't have to simplify my final square root. I'm just going to do all of the math under the square root. So follow me real quick. -2 minus 1. -3, square it. 9. So this is 9. Plus 5 minus 8. Square it. 9 again. So we have 9 plus 9 will be 18. Yeah? Okay. Which distances could I compare with AB in order for this to mean anything? CD? This is already a parallelogram. I already know that those are equal. So we would want to look at, does everyone understand why I know that AB and CD have to be the same? It's already a rectangle, so we already know that the opposite sides are the same. I don't have to show that. All I have to show is that AB with one of the consecutive sides, so I could do CB or I could do AD. I just have to show that two consecutive sides are the same, right? Does anyone not understand why that's enough? Okay. So I'll do this with BC. It sounded like people wanted. So if we're looking at the points BC, we would do 1 minus 4 squared plus 8 minus 5 squared. All right, let's do the math and see if it's 18 under the square root as well here. So what's 1 minus 4? Negative 3, square it, positive 9, plus 8 minus 5, square it, 9 plus 9. All right, so I got congruent consecutive sides, right? So I need to conclude that. So you would do your little this thing and say consecutive sides are congruent. And I would kind of even put in here that you have consecutive sides of a rectangle, so you're showing your viewer that, reminding them, hey, I had a rectangle. Consecutive sides of a rectangle are congruent. And then that will convince them that this has to be a square. And then you can circle your very final answer. Are there any questions on that one? So again, for any of these problems, you should always have this very first chunk no matter what. Depending on what you get up here will tell you what you need to show for your last few steps to tell me specifically what type of thing this is, right? Let's take a look at one more example. Just make sure we're seeing all the tricks, and then I will send you off on your homework. Okay? So remember, we always start by sketching our little figure so that we can see where things are. So this goes in the order of M, N, O, P. What do we check first? Slopes of the, of the opposite sides for all pairs, right? So I should have, how many slopes total should I be doing here? 4, before I even start to draw any conclusions, right? So let's first find the slope of, slope of what? Mn. Okay, sounds good. So for Mn, you should have a slope of negative 1 minus 2 over 3 minus 9. Okay, do the math. You get negative 1 minus 2 is negative 3 over, what's 3 minus 9? What is negative 3 over negative 6? What? Positive 1/2. Very good. Okay. Which slope do I want to compare to Mn? OP. So you've got the slope of OP equals, if you're looking at OP, you should have 8 minus 7 over negative 2 minus a negative, which will be plus 2. So 8 minus 7 over negative 2 minus negative will be plus 2. Okay. So what do I get here? Technically, you get 1 over 0, right? When 0 is in the denominator, what does that mean about your slope? Can you ever have 0 in a denominator? That's undefined. Yep. Something that I want to point out, because it'll show up on the homework, is that any slope that has 0 in the bottom does not exist, right? Does it really matter what number is up here? No. So anytime you have 0 in the bottom, are slopes going to be the same? Or are the lines going to be parallel, I guess is what I'm asking? What kind of a line has a non-existent slope? Do you guys remember that? What kind of a line has a slope that can't exist? Vertical. On the right track there. Yep. It's a vertical line. Again, does it matter what this top number is if it's over 0? So I could have 8 over 0 and it would still be an undefined vertical line, right? Any two vertical lines, are they going to be parallel? Yes. So this is something that you have to watch out for, is that a lot of people will get like 1 over 0 and then 8 over 0 and say that those lines aren't parallel because they don't look exactly the same, but technically they're both undefined slopes, so they are both parallel. Same goes for if you have 0 on top, because if you have 0 over a number, what does that simplify out to be? 0, right? And any two slopes that are 0 are going to be parallel. So when you have the case of the 0, it really doesn't matter what number is on top or what number is on bottom with it, because they'll still turn out to be undefined, or they'll still turn out to be 0, and they will be parallel. The one thing to watch is, do they both have 0s on the bottoms, or do they both have 0s on the tops? That's what will make them parallel. Is there anyone who doesn't get that? Okay. Either way, though, for these two, are these both undefined slopes? No. So these are both going to be non-parallel. Bree?
I was just going to say, can't you just stop after this once you know technically that you have, but like, don't you already know that it's a non-parallel?
You know it's a non-parallelogram, but you don't know yet if it's a trapezoid.
Okay.
So you would still need to find that last pair of slopes to see, do I have one pair of parallel sides?
Okay.
Yeah, and that's a good question.
What does DNE stand for?
Good question. I meant to tell you. DNE stands for does not exist. So it's shorter to write than undefined and has the same meaning, right? DNE stands for does not exist. It's just shorter notation than writing out the word undefined.
I just like to know and write it
Huh?
down. I just like to know and write it down.
Yeah, no, that's, I meant to tell you guys, I just forgot. Okay, so let's keep on going. We do need to see if I have at least one pair of parallel sides. So which slope do you want to find next? NO, very good. Okay, so if I'm finding the slope of NO, I will have 7 minus a negative to be plus 1, and then negative 2 minus 3. So 7 plus 1 over negative 2 minus 3. So if I go through this, I get what on top? 8 over, does that simplify? So that's just negative 8 this, because I only had one negative, so I retain it, right? Okay. How about the slope of, what's the last slope I need to find? MP. Okay. So looking at the slope of MP, we should have 8 minus 2 over negative 2 minus 9. On top, we get over negative 11. So does 6 over negative 11 simplify? Okay. Do you get any pairs of parallel lines? No. So we need to write this conclusion. Draw your parentheses to tell me what it means. So we would say no opposite sides are parallel. So what does that tell us, that no opposite sides are parallel? It's a non-parallelogram. Is it trapezoid? So what are your only options here? It's either just a kite or just a straight up quadrilateral, right? Just no specification. So yeah, it's either a non-parallelogram in general, or it's a kite. We have to be as specific as we possibly can, right? So it could be that a non-parallelogram is as specific as we can get, or it could be that a kite is the most specific I could get. How do I check to see whether it's a kite or not? Check all of the distances of the sides, right? It is possible to have one pair of consecutive sides be congruent and the last pair not, in which case it would not be a kite. So most of the time you're going to have to check all 4 sides. there will be one instance in which 3 will be enough to say something. So I'll show you what that is. So let's start checking our, how are we going to see if the consecutive sides are equal? What formula? Distance. So which side do you want to start on? MN is easiest, right? Hey, none of that. All right. I don't know why you would be yawning. This is just so exciting.
No, it's just the lights. The lights are what got me.
Having the lights off?
Oh, yeah.
We're trying to save energy. Stop being
Good job.
a world hater. What?
What's it?
Did you just say we're the richest school? I disagree with that. I was going to say the school is definitely not. All right. I'm poor. All right. All right. MN. Distance. What is it going to be? 9. And then square it. Good. Don't forget the square. Plus, and then we'll have 2 which will be, yep, 2 plus 1 squared. So we can do our math in our head at this point. You've shown me that you know the formula, so that's really, what I'm going to be checking. 9 minus 3 is, square it, 36. Keep that in your mind. 2 plus 1, square it, 36 plus 9, 45. Which side would I check next? Would I check an opposite side in a kite? No, I want to see if I have a consecutive side. Do we know which consecutive side might be congruent though? Like, is there any reason to know that whatsoever? So if I check NO and it's not congruent, do I get to just stop? No, I'd have to check MP as well because MP could be that congruent side, right? All right, but we'll go ahead and we'll check NO for starters, just to go in order. So when we do NO, we get 3 minus a negative, so plus 2, squared, negative 1 minus 7 squared. Do the math. So 3 plus 2 is 5. Square it. 25. Hold that. Negative 1 minus 7. Square that. So what is 64 plus 25?
89.
Very good. So I know that NO is not congruent, but it could still be that MN's congruent side is MP, right? So let's check that. All right. So with MP, we would have 9 plus 2 squared plus 2 minus 8 squared. So let's do the math. We get 9 plus 2 is 11. Square it is 121. Don't get ahead of me.
I was going to the answer.
I'm sure you were. 121. 2 minus 6, 8. Negative 6, square it. So what's 121 plus 36? Okay. Is it possible at this point for this thing to be a kite? This is the only case where you don't have to do all 4 distances. Is if you get right off the bat 3 different numbers, because a kite should only have 2 different numbers in it, right? It should have one pair of sides that are the same, consecutive, and then the other pair of sides that are the same, consecutive. Okay? This is the only time where you get to stop short. If we had found like square root of 89, square root of 89, and then square root of 157, I don't get to stop there because it is possible for a 4th side to not be congruent to the 3rd one. That's possible. in which case this would be a non-parallelogram, okay? So you need to see if all 4 sides have matches, if this is working out. Now here we know that it's not even possible because I have, within 3 sides, I don't have at least 1 pair matching at this point. So that's enough to say it's not a kite.
So if it was like square root 8, 9, square root 8, 9, square root 45, and square root 45, then it would be.
Then it would be a kite, but you do have to check that last square root 45. Yep. So now we draw our conclusion. What would we say about this? Like, what did we just verbally say? We can say that there's at least 1 pair. So there's no consecutive sides that are congruent to. And which side do I know I have no consecutive sides congruent? Which side did we check? MN, right. So I can say no consecutive sides are congruent to MN. So what does that tell us?
It's not a kite.
Not a kite. In which case it is a non-parallelogram. You guys feel good on this? All right. Let's do the homework then. You only have 3 problems, so I really want you to put your time and effort into understanding these 3. Once you are done with these 3 problems, you can come up and grab the extra credit from me, but I want to make sure that you've gotten through these problems first. All right?